7th grade lesson 13.1 is theoretical probability of simple events. We have done experimental probability, and we tried things and we figured out how many times out of how many possibilities things would happen. That was experimental probability. So what in the world is theoretical probability? Let's have a look. So the example they give us to explore this is that at a school fair, you have a choice of spinning spinner A, do, or spinner B, do. You win an MP3 player if the spinner lands on a section with a star in it. Which spinner should you choose if you want a better chance of winning? So in order to figure this out, we're going to look at the probabilities of each. What are the possible probabilities of each? On spinner A, what is the total number of possibilities, outcomes, that this little spinner arm can land on? There's 1, 2, 3, 4, 5, 6, 7, 8 total possibilities. And on spinner B, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 possible outcomes. Okay. What is the number of sections that have stars in it? On spinner A, there are 3 sections. And on spinner B, it looks like there are 1, 2, 3, 4, 5 sections. All right, the probability, this P is standing for probability. The probability of winning an MP3 player would be to divide the number of sections that have stars divided by the total number of outcomes. So 3 divided by 8 in this case. I almost wish they had reversed this information, but whatever, we'll go with it. 3 divided by 8, and then we would do 5 divided by 16, because we're always doing the ratio of what the possibilities are, or not possibilities, I don't want to use that word. Let's use the word the goal amount, the stars on them, over all of the total possibilities, all of the sections for the spinner. So we're always using that ratio to find our probability. So I'm going to go ahead on my calculator and do a 3 divided by 8. That is 0.375. Let's make that a percent because we tend to talk about these probabilities in percents. Move that decimal twice over. That is 37.5%. We could just call that 38% if we wanted to. And now let's do the 5, the goal being the stars, divided by the 16 possible sections that are there. And I get 0.3125 as a percent. That is 31.25%, or we could just round that to 31%. Well, now that it's broken down into percents, I can see which is the better option for me. I want a higher percent chance to get that. So the ratio for spinner, compare the ratios of spinner A and spinner B. The ratio for spinner A was 37.5%. I'll just call that 38%. Oh, they don't want a number there. I'm sorry. The ratio for spinner A is greater than the ratio for spinner B, which was 31%. So I should choose spinner A for a better chance of winning. Theoretical probability is a way to describe how you found the chance of winning an MP3 player in the scenario above. So using the spinner example to help you, explain in your own words how to find the theoretical probability of an event. So maybe we're putting marbles in a bag and we have different color marbles. Let's say there's 5 red marbles and there's a total of 25 marbles in there. What would the probability of us pulling a red marble at? Well, let's say there's an equal amount of marbles. There's 5 red, 5 green, 5 blue, 5, whatever colors. I can't think of them until there's 25 in there. It's got to be an equal amount for theoretical probability. I think let's go on to the next page and that will make more sense. All right, so here we get the definition of theoretical probability. It's the probability that an event occurs. You haven't tried it. It's not experimental, not yet. That an event occurs when all of the outcomes of the experiment are equally likely. That was kind of the key words that got me hung up when I was trying to talk about the marble experiment. And the way you calculate theoretical probability, the probability of an event, is you take the number of ways that that one event can occur and you divide it by the total number of equally likely outcomes. So On that spinner option, probability can be written as a fraction, a decimal, or percent. For example, the probability you would win spinner B is 5 out of 16. You divide 5 divided by 16, and you will get 0.3125 as a decimal. To make that a percent, remember percent means out of 100 multiplied by 100, and that just moves that decimal 2 spots over because of 100's 2 zeros. And so we move it 2 spots over and we get 31.25%. So this is that ratio we're looking for each time on all of this stuff you're doing, if all events are equally likely. Here's a marble one. A bag contains 6 red marbles and 12 blue ones. You select one marble at a random from the bag. What is the probability that you select a red marble? Write your answer in simplest form. So we need to find the number of ways the event of a red marble can occur, and that's 6. Then we add that to find the total number of equally likely outcomes. There's 6 reds and 12 blues for a total of 18 marbles in there, right? So there are 18 possible outcomes in the sample space. So we use this ratio, 6 red events, 6 possibles, out of 18 total marbles in there. So the probability you would select a red marble is 6 out of 18, and that's a fraction that's reducible. So when we see that, we go ahead and do it. That's 1 divided by 3, or 1/3. And you may know by now, 1 divided by 3 ends up coming out to 0.33 repeating. So we could just call that 33% if we want to. That repeats. I'm just rounding to the nearest percent on that one. So that's just kind of walking you through. Really, it's just concentration on this ratio, the numbers of ways that event can occur, and the total of equally likely possibility outcomes. So the next part is comparing theoretical and experimental probability. So remember, experimental probability was just you trying it and seeing how many times that event occurred over how many times you tried. And theoretical was what are the possibilities that that event can occur, the numbers of ways that event can occur over how many total possibilities there are available. So we would find, to compare them, you would figure out what's the theoretical. In theory, what is the probability the event will happen? And then you would try it and experiment with it. And you would compare your results to the theoretical probability to see how close it was. It should generally be fairly close. It's not always, but generally it tends to be fairly close. So let's have a look at this example. Now that you've calculated theoretical probabilities, you may wonder how theoretical and experimental probabilities compare. Ideally, pretty close. 6 students are performing in a talent contest. You roll a number cube to determine the order of the performances. You roll the number cube once. Complete the table of theoretical probabilities for the different outcomes. So here's our number 1, 2, 3, 4, 5, 6 number of numbers that can be rolled. And so the number of a 1 being rolled, there's only 1 out of the 6 sides of the dice. Chances of a 2 being rolled, there's only 1 2 out of 6 sides of the dice. Chances of a number 3 being rolled, well, there's only 1 3 out of 6 sides of the dice. All of these, right? So they want us to predict the number of times each number will be rolled out of 30 total rolls. So if our probability of a 1 being rolled 1 time out of 6 rolls, how much is that if I roll 30 times? Well, I can see here, if I'm looking at equivalent ratios, 6 times 5 is 30, so 1 times 5 is 5. So that means, theoretically, a 5 would come up 5 times out of your 30 rolls, and since that calculation will be the same for all of these, theoretically, out of 30 rolls, you should see 5 of each of those. Now you understand in the world that even though you would expect a certain amount of things to happen theoretically, things are random and odd, so it won't be perfect. It would probably be close, but it's not going to be perfect. That is our theoretical probability. Now we're going to go step 3, go into, let's do the experiment. Let's experiment and see what comes up. So we'll roll a number cube 30 times and then we'll complete the table for the frequency of each number and find its experimental probability. Okay, and then I went ahead and did the experiment. I rolled a 6-sided cube, a dice, 30 times, and I used hash marks to mark how many times they showed up. Remember, our experimental probability was that they would show up 5 times each. Oh, I'm sorry, that was our theoretical probability. Our theoretical probability is they would show up 5 times each. Our experimental probability was out of those 30 times, 1 showed up 4, 5, 6, 7 out of 30. 2 showed up 1, 2, 3, 4, 5 out of 30. 3 showed up 4 out of 30. 4 showed up 5 out of 30. 5 showed up 4 out of 30. And 6 showed up 5 out of 30, which was fairly close to our theoretical probability. It looks like the 1 showed up a few more times, but a lot of those showed up as the theoretical probability predicted. Look at the table you completed. How do the experimental probabilities compare to the theoretical probabilities? You could word that how you want. How do these compare to these? We expected each of them to show up about 5 times, and they kind of did. There was a few exceptions. By performing more trials, you tend to get experimental results that are even closer to the theoretical probabilities. So we could combine our table from step 3 with those of our classmates if we were in class and make one big table for the class, because if 20 of us did the rolling of the dice 30 times and we combined our data together, we'd have a lot of experimental trials to base that on, and we would end up getting closer and closer and closer to whatever the theoretical probability would be. And that's really what this lesson is about, is getting that ratio for theoretical probability, and then you might even compare it to the experimental probability and try it, just like we did with the dice. So that's all this lesson is. Hopefully you feel pretty comfortable and confident with that. Good luck.